Review for the unit test. Again, like I just mentioned a moment ago, same setup, same types of questions when we get to the real one tomorrow. We start, though, where our whole basis of algebra is. Equation solving. Now, one thing else I will mention as we get this first one set up, the show all work is not me trying to be a jerk and make you show a bunch of things. It's to help you if you make a minor boo-boo somewhere. It lets me say, oh, that's the only place there's a problem. I'll only take off a half point versus, oh, that's just wrong. It's -3. Okay. Probably a good idea. The other thing I'll mention as far as equations go is the difference between when my x's are on opposite sides of the equals, and I have to do an opposite to get them together, versus something that's going on down towards the bottom like on number 5. But we'll talk about that when we get to number 5. So I like to keep my x's positive. So I'm going to minus the 8. And then again, it just becomes, can I get my x by itself? What's the opposite of minusing 5? Well, it's be the plus 5. And then I divide by 2. Okay, not bad. Not bad at all. And so as I go through these, there's just going to be a few little differences to see if you're really, locked into what's going on here. So for instance, on number 2, we've got some distributing to do on both sides. Remember that it's a negative on the left. Make sure that 2 goes to both terms, even the x. On the right. Very similar again to what we saw in number 1. If you always like having the x's on the right, add the 2x over. I always like having the x's be positive because it's one less thing to think about later. So I'm going to choose to move the negative 4x. But no matter which side your x's end up on, okay, be careful here. I always tell people if you need to, put a little plus in there to remind you I'm adding 10. So we're just going to minus 10 over. And then divide by 2. And we're set. Now, equations won't go away. They're just going to take some different formats here as we continue. Like on number 3. I believe I was nice on the test as well and put the parentheses in, but if I didn't, you need to remember to. Because when I go to cross multiply, that 8 needs to go with your x and your minus 2. The 3 needs to go with your x and your plus 6. So when I go to distribute, that goes through. And now it just basically looks like numbers 1 and 2 did. I'm going to work on getting my x's together. Once I do that, I'm going to isolate my x term. I'm going to add my 16 over. And don't flip out if you get to a point where you get something, you're like, wait a minute, 34 divided by 5. Harty, it's a decimal. No worries. Okay. I'd prefer at this point if we'd go then and hit math, enter, enter, and go back to a fraction and leave it at 34 over 5. But I'm not gonna jump up and down and holler at you if you left it at 6.8. It's still the right answer. But you can get some fractions and stuff, so don't worry. Speaking of fractions, okay, this has been one of our kind of Achilles heels on some of the quizzes so far. Here's the one thing I can tell you. I can't do one common denominator for this side and one for this side. Okay? More times than not, that's going to cause issues. So if you're not sure, and you're not comfortable saying, well, 2, 3, 4, and 6. If I started going by multiples, so that's 12. And multiply through by 12. We've talked about how you can say, hey, I'm just going to multiply all the different denominators together. If any of them are the same, I don't need to use them twice. And then that's the number I'm going to use to distribute through. Now, that number's big, but we have a calculator. So when I go to multiply 5/3 and 1/44, one way I can do it is just to put a set of parentheses next to it. That works, because the whole idea is to get rid of the fractions. My other way I could do it, if I was worried that maybe I'd forget the parentheses or something, is that we're going to multiply by the number on top and then divide by the number on the bottom. That also gets me 240. So no matter which way I choose to do it, but don't forget your X on that one, because that would be kind of tricky otherwise. So I get rid of all my fractions. And now again, just like 1 through 3, it's just having to get through that one step to get there. So it really just becomes, do you have the patience to kind of work your way through? Add my 180 over. And divide by 120, and again, break this out. 2.1, math, enter, enter. We prefer 21 over 10. I will not scream at 2.1. Okay? But again, show your steps so you're getting the points even if something doesn't quite right. And the one last twist in the equation portion. We talked a little bit back up at number 1 about how when your x's are on opposite sides of the equal, we got to do an opposite. These x's, in this case, are not on opposite sides of the equal. We just combine them. 3 minus 5 is negative 2x. And now it's just like the rest of them. Move your x's to whichever side you would like by using an opposite. Got to be an opposite now when they're on opposite sides of the equals. Isolate your x term, whatever's being done to it. We'll add the 7 over. And we'll divide by 6. Again, if you've gotten the practice, that's not going to be a bad thing. If you haven't, oh yeah. Speaking of practice, I keep leading these in really well. Some of you are still flipping out about some of these at the bottom. And again, you've got to practice. You've got to. It's the only way you get better. I went back and looked at the videos and some of the stuff that we've done over the weekend a little bit. This is going to be like the 9th time in class we've gone over this. So we've got to lock in here. We're still, even though there's a lot of variables, don't let that freak you out. We're still trying to get A alone. What am I doing to A? Multiplying it by 3 and t. So what's the opposite? Divided by 3 and t. One step, I'm done. Now, unfortunately, they're not all quite that quick. Because I get to the next one, and I'm like, okay, b. How do I know whether I do the minus 5a first or the divide by 2x first? Does it matter? Yes, it does. I can't do the minus 5a because this is still here. So I always tell people, this is attached to the b. This is not directly attached. This is what I want to do first. So since the opposite of divide is to multiply, that's what I'm going to do first. But I got to do it to both sides. We like dumping fractions first when we can. Okay, 2xy. No pluses. We didn't add it. We multiplied by it. Now I look and I go, okay, b, want to get b alone. What's with it? Minusing 5a. What's the opposite? Adding it. And I get there. Okay? It's really no different than the equations were up top. The steps and ideas are the same. It's just it's letters instead of numbers you're doing it with. And our final one, the one that is showing up on every single quiz and test for who knows how long. I'm solving for p, but there's more than one p. What do? I take a p out, take out what they have in common, and then I say, okay, so to get from here to here, well, I've already got the p. I need the 2. And to get from here to here, I've already got the p. I need the t. If I were to go back and distribute now, p times 2 is 2p. P times negative t is negative pt. I should get the same thing back. But for us, the big thing is now that I want to get p by itself, now there's only 1, the parentheses mean I'm multiplying by this stuff, and I've got to do the opposite. At this point, we got to be able to slam through that. If we're leaving that blank now, it's due to not practicing and saying I can't, just giving up on it. So we really got to take a peek at that. So, all right, I think that gets us away from straight up equation solving here for a moment. So as we flip over, okay, choose the interval notation that best describes the graph. Hey, if there's multiple choice, take advantage. For instance, I notice this is going forever to the left or towards negative infinity. That doesn't have a negative infinity. It's not that one. That doesn't have a negative infinity. It's not that one. It's got to be one of these two. So what else do I think about? It's left to right. Well, left means I got to start at negative infinity. That doesn't start at negative infinity. It's this one. In my last tiebreaker, I'd be looking at the symbol. You know, is it a parenthesis or a bracket? Oh, it's a bracket. Okay. So kind of just work down the checklist, and you'll be able to narrow that down and get it set. Solve the inequality. Not absolute value, just solve what's here and graph it. Add my 7. Like, 4 divided by 4. Already it's a decimal. That's okay. When we're graphing and you get a decimal, I understand you not putting it to like 17 over 2, because that's tricky to graph. So you're like, okay. As long as you have at least 3 numbers on your graph, I really don't care, you know, how much that gets going. So x is less than is left, starting at 8.5. Less than means just a parenthesis. And it does not say do interval notation, so just graph it, be done. And that's the same idea on 11. Minus my 8. Oh, we got to be careful this time, though. I'm dividing both sides by negative 2 to get that alone. What strange thing happens to my inequality when I divide both sides by a negative? Yeah, we got to flip the inequality arrow. Okay? Only when we multiply or divide both sides at the last step. So again, I'm jotting my values down here some. Again, I notice the x is being pointed at by the inequality arrow, so it's less than or equal to. So this time it's a bracket. And I go on about my business. Taxi company charges a fee of $10 per ride plus 80 cents a mile. Write an equation that describes the relation between miles and cost. Okay, now again, you don't have to write out a verbal sentence, but it may help. So my ride fee plus the number of miles I go equals the cost when I get into this taxi. So as soon as I get in, they charge me $10. Now, if you want to put an R on that, you could, but it wouldn't be necessary here. It costs 80 cents for each mile. And that's going to be how much it costs. So either 10 plus 0.80 M, or you can put the R in there. Because I don't know why you take multiple rides at once, but maybe. Maybe you went to the wrong place. I don't know. Kind of work it that way. 13, I discussed with a few of you when we last met. and said, this is a different setup than the ones we're used to. We're used to being able to just go sentence, equation, sentence, equation. And that's the way I'm working on setting them up for the test. But let's show you how this would work just in case. So Jen is buying plants for her garden. We've got petunias cost, a tray of marigolds cost. She wants to plant this many flowers and spend this much money. So we're going to have a flowers equation and a money or cost equation. This is going to set up a little bit differently. So I look, a set of 12 petunias, so that would tell me how many flowers she gets of those. Cost $8 each. So the petunias cost $8. So notice this time, I got part of 2 equations, but I didn't get all of one. A tray of 16 marigolds, again, number of flowers, cost $6 each. Cost of the marigolds. Jenna wants to plant 348 flowers and spend a total of $190. So I ended up with my 2 equations, my system. And this time for my variables, my P and my M, it'd be the number of trays of petunias. You can't just put number of petunias because, the number we're going to find is the number of trays. Same with my marigolds. It's got to be number of trays. Be specific when you're describing what your variables stand for. Okay, just read it back over for a second. And the more specific, the better off you're going to be. And that's what we're looking for there. Like I said, though, I believe the ones that I put on the test are more like the ones where it's just sentence go. But if not, let's make a little bit of an adjustment. Solving by graphing, reminder. We always take the number on the end, the y-intercept first, and plot that. So that first point here is going to be on this axis. Second is going to be dealing with my slope, which again is rise over run. How much do I go up or down versus how much do I go left or right? If it's not a fraction, make it 1. Up 2 and right 1 from my y-intercept. Up 2 and right 1, up 2 and right 1. If you run out of room, remember we can do the opposite of both to keep going. So instead of up and right, I can go down and left. Down and left. Down and left. And I don't even care if you actually put a line through there or not. Because again, with the dots, we're trying to see where the dots have something in common. When I do it on the second one, there's my y-intercept. When I don't see numbers in front of x, we assume they are 1s. Up and right, up and right. Bingo, there's the one I want. So at this point, if you stop, it's okay. Because again, the point they have in common is what I want. What point is it? 1, 2 for my x. 1, 2, 3, 4, 5 for my y. But you have to at least graph the dots. If you leave the entire graph blank and just try to mentally play around with it, you're going to lose the points for graphing, and that's going to be a major point of those 2 questions. So don't get cute. And the same idea on 15. Y-intercept is negative, so I go down. Slope is negative. The negative's only on my number on top, though, so instead of going up, I'm going to go down. So down 2 and right 1, and I ran out of room already. So instead of down and right, up and left, up and left. In that first one, we're going to have to dot as far as we can because we don't know how many dots we're going to need. I look at my second one, dot my 3, up 1 and over 3, up 1 and over 3, but we got to go the other way, down and left. We got a bingo there, down and left. And so again, there's my point that we have in common. So to get there, left 1, 2, 3, and up 1, 2. And we're good there. That was only our first way of being able to solve our systems, though. We also had substitution. Again, where you're going to have x equals or y equals, pay attention to which variable is solved for. If it's y, we're going to take what's in the box, we're going to plug it in where the y is at. Okay, we're set there. Thank you. So I take the equation that I'm plugging it into. Everything stays the same except the y, which we're going to replace with what's in the box. Okay, so the minus has got to stay there. We've got to distribute that negative through. And now it's all the little things. It's all the details. They're on the same side of the equals. Don't do opposites. Just put them together. 5 minus 1 is 4. Add my 3 over. And don't panic when you get to this step. Remember, I'm dividing by 4, because that's what's with x. Harty? I didn't get a whole number on an elimination substitution problem. Is that okay? Yeah, it is. Okay. Whether you use a half or 0.5, don't care. But I got one step left, and that's to plug this into the y equation. You just look at that and say, can I write 3.5? Absolutely. If you go to your calculator, if you're like, I just want to be sure. Can I write 3.5? Yep. Can I write 7 over 2? Yep. Any of them are fine. Okay, I'm looking to see that you can do the work right. I cringe a little when we get to the decimals, but I'll make it work. I'll survive. And then just one more of the same. Again, it's going in for y. Watch your variables. Distribute that through. Same side, just combining like terms. Isolate my x term by adding 4. And then I get to do the easy part. Y equals x minus 2. And get my y. But again, same process we're working through, just kind of playing with those a bit. And finally, our last one that we deal with, we've dealt with this the most, is elimination. Always look first to see can you add down and get rid of a variable. 2 plus 6 does not get rid of x. Positive 1 and negative 1y cancels. Woohoo! Less work for me. So I just add down, and I'm going to have to solve that one-step equation. I divide by 8. But you're not done. There's 2 variables. Normally what I do is I just use the top equation, but you can use whatever equation you want. Take the negative 1, plug it in for the x. Get that simplified down a bit. Add your 2 over. Get my answer. Got to keep reminding myself if there's 2 variables, there's 2 answers. Got to play it through. Now, I'm not quite as nice on 19. 19, 4 plus 1, that doesn't eliminate. Negative 1 and negative 2, that doesn't eliminate either. So then I start with my first variable, and I go, okay, I'll look at the smaller number. In this case, it's 1. Can I multiply 1 by something to get to 4? If I can, I'm going to multiply through. But I have to check one other little detail. 4 times 1 is 4. Does 4 plus 4 eliminate? No. 4 minus 4 would, though. And if you multiply through first and then find that out, you can always go back and do the negative later if you forgot. Not the end of the world. Down here, my negative 4 has got to distribute through to everything. The x term, the y term, and even that. Divide by my 7. And once again, I've got to solve for my other variable, which this time is x. So let's just keep going to the top one here. So I'm going to plug in my y value. It's the little stuff where we're going to gain or lose points. Minus a negative is plus. It's about the only time in life that two negatives make a positive. Minus my 4 over. And divide by 4. Not too bad. But again, just show my work, kind of make sure I got this going. All right. So as we flip to the back, all right, here come the absolute values. Absolute value, equation, interval notation with my inequalities. Got to have 2. Both solutions, 2 solutions. First equation, just copy what you got. Second equation, copy what you've got in the absolute value. Change the sign of the answer. That's all we do that's different. Whole numbers are cool. Fractions are cool. Doesn't matter. Okay, minus my 4. Divide by 3. Minus my 4. Divide by 3. And again, if you put 6.7, negative 6.7, I won't scream too much. I'll just, a little bit. And then you're like, okay, why'd you do 21? Because it's just like 20. Here's why. And we talked about that some, and we had that up on the board for the past couple of days. You have got to make sure that your absolute value is isolated before you split these. If you don't, you're going to mess up one of your 2 answers. So here, to make that happen, get that in there. Now I can split it into 2. And change my sign on the second one. And solve for x. So isolate if need be, but then just split them up and go. There will be an error analysis question here. The one I put on here, for those of you that asked me about it, again, when we last met, this one is trickier than the one I will put on the actual test. On the test, there always will be, if I say, is she correct? The answer is always no. There'll always be something wrong. But some of you came up and you said, but she did everything right. Like here, okay, she just left it the same. Switch the answer, that's right. Add 1, divide by 2, that's right. Add 1, divide. She did everything right. Mathematically, yes, but here's where the issue is a little bit different. When we have absolute value problems at the beginning, okay, we know that absolute value only comes out positive or 0. Okay, even though we put that negative as the second one, it's not with the absolute value. So you even could have said something like your starting problem can't have a negative answer, okay? Like I said, tomorrow it'll be something like, I'll switch a sign here, or she did some math work wrong down here. It won't be something that complex. But now you'd be ready for it even if I did do the same thing. So either way, I don't feel too bad. And finally, I think we're actually going to make it, unlike last time we tried this. Solve by showing all work and state the solution in interval notation graph if needed. Okay? My first thing here, because I know when I do these, I leave the first one alone. When I get to the second one, I flip the arrow, I change the sign. I do two things. But here's the thing that's going to help me when I get to the end to know if I did it right or not. Is it an and? Is it an or? If the absolute value is greater than, okay, if the arrow's eating this, remember that is going to be an or, which is going to give me an idea of what the graph looks like. So once I get done solving the inequalities, now I have this picture in my head of what this should be looking like. You're like, but there's no line. Well, I'm going to make one because I think it's important enough to visually be able to see, did I do this right or not? X is greater than, arrow's eating it, greater than means go to the right at 9. X is less than 3, less than goes left. It matches, I feel good that I've done it right. Now I've got to do the interval notation, which this is not interval notation. Interval notation is when you do left to right. Left is forever left. To right. Then we hook that up, starting at the next starting point, and off forever to the right. So your ors are going to be really big intervals. There's a lot more space they're taking up. Unlike your and, like number 42, and again, how do I tell the difference? If the arrow's pointing at it, if it's less than, that's an and. Those are the little tiny guys. The setup is the same. I still just copy it the first time. Switch my arrow, switch my sign. Minus my 3 over. Divide by 2. Here, minus my 3 over. Notice I'm dividing by 2. Do not flip the arrow again. Even if you tried to, if you graph it, you're going to find out that would cause you a problem. Okay. And graph them again. I'm just being sure I'm getting that visual picture that I did this right. X is less than or equal to 2. X is greater than or equal to negative 5. Makes me smile. Matches up. And I do my interval from left, which is starting at negative 5, to the right, which is my 2. Okay? Not hard to get through this if you've practiced enough, and you'll hit a little bump here and there, but not to stare at a problem for 5 minutes. So when you come in tomorrow, basically when the bell rings, I'm going to go, and I'm going to get out of the way here. So if you need another one of these, grab it out of the folder. It's also online. I'll have this video, hopefully if it's working well, uploaded by this afternoon. So if you want to go over a couple more things, you can. And otherwise, get ready, get ready, get ready.